Alright, these are your notes for section 5.9 on complex numbers. Now, we'll talk about what complex numbers are, but they're just a way to write imaginary solutions, imaginary numbers, okay? And remember, we talked about in the last video, imaginary numbers contain I. So, what is a complex number? Well, a complex number contains I, which means it's a non-real solution. I couldn't find it on a number line if I wanted to. Contains I, and it's written in the form a plus bi, and a and b are numbers, okay? For this particular video, we're going to look at what happens when a is 0. So we're just going to be talking about the bi part of the problem. In our next video, we'll talk about operations where we have complex numbers, full complex numbers, a plus bi. But for this particular video, we're just going to talk about the bi part. Now, we already know that I equals the square root of -1. So my question is, what is I squared? If I equals the square root of -1, then I squared would have to equal the square root of -1 squared. When I have a square root squared, they cancel each other out. So I squared really equals -1. And this is a big idea. Okay? I squared equals -1. Now that we know that, we can solve some more types of problems. I've got some examples here, and we're going to multiply that bi part of a complex number. We're going to have a number in there for b and then an I. We're going to multiply those together. So let's look at our first example. We have -3i times 2i. We're just going to treat that like it's a variable at this point, the I. So we have -3 times 2 gives us -6, and then I have I times I, which is I squared. Now we're not quite finished because we just figured out that I squared is -1. So we're going to rewrite this now. -6 times -1 gives me the answer of 6. And that would be the answer to this problem. Okay? So we multiplied two complex numbers together and we got a whole number. We got the number 6. That's a real number. Let's look at another example. We have -6i times -7i. Well, -6 times -7 is going to be positive 42, and I times I is I squared. I squared, though, we can't leave it I squared. We switch it out because I squared equals -1. So now we have 42 times -1, which is -42. Okay? So we've multiplied them together. We had two complex numbers, the bi parts of the complex numbers, and we got another whole number, a real number answer. We've got one more problem to look at. This one's a little different. We have square roots here. Now, when we have square roots and negatives in the square roots, we need to simplify first. Okay, and then we multiply. Do not go ahead and multiply them together first. We have to simplify them first, or otherwise we'll get the wrong answer. So let's break these down. That negative is going to come out in front and become an I. So now we have I root 12. Over here, same thing happens. I square root 2. That's really what I've done here. Split it up and then just switched this negative square root of -1 out for an I without showing that extra step. So you can do that. That's fine. Let's break down our 12 now. 12 is really 4 times 3. 4 is a perfect square, so a 2 is going out in front. That leaves us with 2i root 3 times I root 2. 2i times I is going to be 2i squared, and then 3 times 2 is going to become 6, so a 6 is underneath the radical sign. We still aren't quite finished because we have this I squared, and I squared is really a negative. So we have -2 because we switched that out for a -1 root 6. And there's the answer to the problem. Okay? So we multiplied two complex numbers, two negatives under the radical, two imaginary numbers together, and again we got a number, a real number answer that we could find on the number line. Make sure though when you do those radicals that you simplify first. and then multiply. That's extremely important. Okay, we've got one more type of example to look at here for this BI part, and it says if I is to an exponent, then what do we do? Okay, and there's two different cases. There's a case where I is even and a case where I is odd. We're going to start when I is even, to an even exponent, and we have I to the 12th here. Now our goal is to get an I squared in there because we know what I squared is. I squared equals -1. So what we're going to do if it's even, we're going to make it I squared, and then we have to fill in that exponent up here somehow. Put I squared in parentheses and fill in the exponent. Now it's a power to a power, which means we would multiply those together. So 2 times what equals 12? That's what we want to figure out, and that's going to be 6. So really all we're doing is taking that exponent and cutting it in half. Okay, that's where we get this number. So we have I squared to the 6th, but I squared is really -1. We switch that out. So now we have -1 to the 6th power. That's really -1 times -1 times -1 times -1 times -1 times -1. Now, I don't want you to write this out every time, but these always pair off and become positive ones. So we have 1 times 1 times 1. So the answer to this problem is 1. At this point, you could put it in your calculator, but you have to put that in your calculator exactly the way that it is. Parentheses with a -1 inside, and then the exponent of 6. If you don't put it in parentheses, it's going to give you the wrong answer. It's always going to give you a negative answer, okay? Depending on the calculator you have. More likely, though, it's going to give you a negative answer because it's not going to include the negative in your exponent. So always put that in parentheses. Okay, and that's how we solve that. Now, I'm going to give you a hint here. If I is to an even exponent, you will get one of two answers. It'll be 1 or -1. It cannot be anything else if I is to an even exponent. It has to be one of those two. It cannot be both of them. Your answer is not 1 or -1. It is 1 or it could have the solution -1. There are two different answers. It has to be one or the other. Okay, if that's I is to an even exponent. When I is to an odd exponent, we solve this about the same way. The problem is, though, that we can't get that exponent to as I squared to some power. So what we have to do is pull one of those i's out. So we would make it I to the 34th times I. And then we treat this part here that's even the same way we did over here. We just leave that times I at the end. So now we need to fill in that exponent. We would do 34 divided by 2, which is 17. So we have I squared to the 17th power times I. This, again, is because it's odd. Make sure you keep that I on the outside. Now it's -1 to the 17th power. If I have -1 to an odd power, they're not going to pair up like they did when I had -1 to the 6th. That was an even exponent, an even power, and they all paired off and gave me a positive answer. If I have -1 to the 17th, it's just going to be -1. The reason is I can't pair them off evenly. I can get 8 pairs, which would be 16 of my i's, and then I have that, or 16 of my -1s, sorry, and then I have one -1 left over. So times I, and my answer would be a -I. Okay? Again, do not forget about that I on the outside. That's really important. Now, I gave you a hint for when the exponent was even. When the exponent is odd, it has to be I or -I. Because you've pulled that I out at the very beginning, you split that exponent into an even exponent and then just an I. So you will always have that remaining I in the answer. So you get a positive I or a -I. Now that's kind of difficult to understand, and I realize that. So if you have questions on that, either rewatch this or bring this to class. But the top part, where we're just multiplying things, you should be able to understand on your own. So those are your notes for section 5.9 on complex numbers, just the BI part of the complex numbers. Again, if you have questions, rewatch the video or bring them to class next time.